Hi, my name is German Ramirez. I'm an undergraduate student at California State University of Fresno. My research topic is on very long instruction word architecture, also known as VLIW. My research is focused on how VLIW architecture is used in embedded systems. Due to the growth of the Internet of Things, the demand and the need for embedded systems is increasing. Embedded systems are being used in a great variety of applications, such as digital signal processing, image processing, uh, sensor networks, wireless communications, cellular phones, etc. They're being used everywhere. Also, the complexity of these systems is increasing because of the more and more functions they are offering to the user. Every day, these systems offer new functions to the user. For example, refrigerators now offer internet access to the user. Also, the user is able to play music, play radio, or watch TV on a refrigerator. These increasing functions being offered to the user require systems with enough processing capabilities to handle these tasks. Therefore, we have to find an architecture that provides the required processing capabilities, and this architecture is VLIW. So what is VLIW? Well, VLIW architectures are alternative designs to superscalar processors. Superscalar processors exploit instruction level parallelism through very expensive dynamic hardware scheduling. And like superscalar processors, the main purpose of VLIW architectures is to improve a processor's performance. VLIW are used to achieve a higher performance by being able to execute multiple operations in a single clock cycle. Also, like superscalars, VLIW architectures exploit instruction level parallelism. However, they do it through the compiler instead of using extra hardware resources. In VLIW, the compiler reduces the program instructions into basic operations that the processor can perform at once. These operations are then included. Um, these basic operations are then included into one very long instruction word that the processor then takes apart and passes the operations off to the appropriate execution unit. Figure 1 here shows a generic VLIW instruction format. Based on this instruction format, this architecture can perform 4 operations at once. So this encoding done by the compiler leads to a dramatically reduced hardware complexity compared to other higher degree superscalar implementations of a RISC or 6 architecture. As a result, a big advantage of VLIW is that its implementation is much simpler and cheaper to build. Figure 2 here shows a generic VLIW implementation. This architecture uh, has 4 execution units, and it shares a register file, data cache, here's our instruction cache, and instruction register. This is just a simple instruction, simple architecture, generic architecture.